the OpenSSL Heartbleed incident. So if you would like to be able to come in, sit down, we'll get ready with that. It'll be fantastic. On the panel, we have three people who have different perspective about what happened with handling the OpenSSL Heartbleed incident. And so we've got Megat Mwazam from my cert, Malaysia's cert. He'll be able to tell you about his perspective about what happened and how they handled that particular Heartbleed incident. Then we have Barry Brayley from New Zealand Internet Task Force, and he'll be able to tell you also about how the incident was handled, taken care of. We also have Paul Vixie, and the perspective we really want to be able to have a look at is also that Paul has been coding things which were quite relied upon on the internet, and still is, and the perspective, because OpenSSL is also relied upon, and when it breaks, what happens after that. One of the perspectives that we don't have on the panel right now is actually with the ISPs. We would love to be able to also have a perspective of how ISPs felt when they were confronted with this particular problem. This is important, so if you have questions, please come up, okay? State your name, state your organization, and then the question, and whenever you feel about it, and it'll be fantastic. So the way that this is going to be run is there's going to be two little presentations. Barry will go up first, questions, and whenever you want to, please go right ahead to the mic. For Megat, he would rather have it after his presentation. After that, it's almost a free-for-all. We'll continue with the discussion. I'll try to keep the momentum up. And again, you're invited. Please take the mic. Any questions you've got, ask them. You've got people who've got some perspectives that you may not have, and you may have perspectives that we didn't understand or quite be able to relate with each other. So if everything's okay, I'd like to be able to introduce Barry Brayley to the stand. Thanks.
Good afternoon. Thanks, Jeff. Just wait for the slide. So I work for a cctld.nz domain name commission, but I'm talking here more from my other role, which is as the chair of the New Zealand Internet Task Force. So as you'll see on the slides, the NZITF is a volunteer group, a sort of trust group within New Zealand. And so our role in this came about slightly differently, which I'll cover. So I'm just going to use a few slides to talk through the first 48 hours of how this unfolded in NZ and some of the insights that gave, and then I'll be happy to field questions or take part in other discussion. So that's where I'm from. Like I said, the organisation I'm talking about here, please remember we're not a government department. This is a volunteer collaborative effort. So go back to April the 7th. I suppose the thing here, and I was interested in the time zones and how things unfold at different times. So obviously remembering this was already April the 8th, and at the point that people start talking about this in North America, it's a significantly different time in Asia Pacific, obviously. So somewhere around the middle of the day, one of our NZITF members posts to the NZITF mailing list, and he's one of our less technical members, and he just kind of said, "Hey, is this a thing? It looks like it might be interesting." And then people start to dig around. We check some of the mailing lists that people are across, and we start to follow some of the news. And obviously, over the course of the rest of the day, the media quite literally lights up with it, at least the overseas media anyway. So it turned into quite an interesting afternoon. At this point, I'm still very much sitting in my day job. I'm not thinking that this directly involves me. Later on in the day, a nameless government agency assured us that they were assessing the problem and would be following up shortly. And then, well, not an awful lot really, so it got to the going home time. At this point, the media outlets and the sort of discussions around this are going quite wild, and there's almost nothing happening in New Zealand. And so 24 hours after the sort of story broke internationally, I'm enjoying my cornflakes at home, and I was actually shocked to see that the New Zealand media had not picked up on the story at all. Nothing in the local media. Not one of our fine technical journalists had decided to cut and paste that story from overseas. So that was a little bit surprising. I also checked my mail list, and this is pretty early in the morning. I checked the mail list, and I noticed that no government department or anyone else had made an official announcement or advisory or definitive piece of information. And one of the board members flicks an email. So this is the NZITF board member. He flicks around an email using a few expletives. I won't name which one he was. He is here at the meeting. And he kind of highlighted that we needed to assemble our membership and probably start to think about what the response should be, because the significant lack of activity, given that we were by now seeing exploits in the world and lots of it, was a concern. So I suppose from our perspective, a lot of stuff's gone on overnight, which is the challenge of time zone in Asia Pacific. So like quite literally, while you're trying to eat your breakfast, you're trying to catch up on an incident that's already several hours in, whilst our country's been sleeping, and we can't see any time soon that that's going to get resolved there. So slightly apprehensive start to the day. We email around our membership. We figure if we can get at least a few of the right people onto a conference call, then we can start to pull this together. And so this all, obviously, how it all came out is something that we can cover off with Jeff shortly. The whole run-up to this was slightly unusual. I know from my response days when I used to work in the government agency, the fighting a response in the middle of a media storm is sometimes harder. The media attention is worse than the actual vulnerability. In this instance, I was actually concerned that there was no media. So we got the conf call going. We got quite a few of our members dialed in from a vast cross-section of our sort of security community. We also used a couple of our members' comms and media teams to actually nudge the local journalists and let them know that there was a reasonably large international story that they should probably be following. That also allowed us as NZITF to start to control the whole media story that the New Zealand outlets were going to run with. So we highlighted to them that they needed to start getting the word out. We also highlighted that by 11 o'clock that morning, we would have the local advice and a website up that they'd be able to go to. So we gave ourselves a whole 2 hours to figure out exactly what that message was going to be and run with it there. But we got quite a good immediate traction. We tried to make sure that we could establish one definitive place for New Zealanders to go to. The fact that it wasn't a government website didn't seem to bother anyone, so that was quite useful as well. We went with 3 simple messages at first. Talking to even our membership, like some of the techie members, they're like, if you go with anything too complicated, you'll just scare them off. So we just went out and we were encouraging the website owners and network operators themselves to establish if their site servers were vulnerable, patch those vulnerable services. By now, the patches have all been released, or most of the patches are released, and then in this order, then revoke and reissue the certificates. And then further down on the release, there was the links to all the different patches. We linked to certain test sites that they could use, et cetera, et cetera. So that was the kind of initial information that we got out. That got good traction. One of my colleagues was on most of the radio stations for TV interviews around the lunchtime period of the day. It ran in the afternoon TV news as well, just a screenshot. That Heartbleed icon went down really well, right? So all the news stories loved flashing that up, and now we gave them a local soundbite. And luckily, the 3 simple messages were carried right through, so they went on with it. We weren't happy about linking to commercial test pages because we were kind of anxious that those companies were going to use that for commercial gain afterwards. So one of our members started work on building our own test page, and we were also thinking of how we were going to scan the whole of .nz and be able to do a more proactive follow-up in that way. And then, luckily, unluckily, one of our members, or a number of our members, are also actually serving police officers, and they highlighted to us that even testing for Heartbleed yourself is notionally a crime in New Zealand. So it falls foul of Section 252 of the Crimes Act. Now, I go to a lot of conferences where ostensibly hackers, pen testers, clearly are sailing a fine line between legality and illegality, and that's fine for them. Doing incident response, and having done it for a number of years, I've never been the one facing that discussion with a police officer, so this was a new experience for me. And we did decide that it wasn't advisable, even if we toned it down to only getting 1 packet of data back in the response, it was still notionally illegal. 1 byte of data back. So we weren't prepared to allow one of our members to expose themselves to a potentially illegal act. So we decided to avoid jail. We actually used the Qualys test page because we found it to be the most reliable, so we pointed all of our people towards that. We also shared, because we couldn't test for who was still vulnerable and start to chase it down in that direction, we shared the details as and when people were publishing the fact that they were now patched and secured. We didn't encourage people to go and also test their other providers because we felt that was a step too far. But we made sure that that information was publicly available. In our later releases, we also talked through, for those affected organizations, we pushed out the comms ideas that they should now be running with to try and get ahead of the issue as well. So the discussion about the law is now causing a bit of a distraction because there's some frustrations amongst some of our members. One of the managed security service providers that's on our membership highlighted that from external sources, 40% of their customer base had been scanned for heartbleed in the first 48 hours. So the bad guys are scanning everything they possibly can, and the good guys are unable to detect the same vulnerabilities and advise the people of it because we'd have been in breach of the law. So that's still a conversation that we haven't closed out, so I'm not going to talk too much further on it. But yeah, it was one of those interesting quibbles around this. I'm sure notionally the same laws apply in a lot of other jurisdictions. There was also a side discussion which amused me. I was talking to one of our larger tech companies, and the security guy turns around to me, and he says that for the first time ever, his words, he's truly relieved to be working in a Microsoft stack company. And for a security guy to say that, that's quite amusing. No offense to Microsoft. They'd actually had a lot of questions from their customers saying, have you patched, have you fixed for this? And they were sick of saying, like, it doesn't affect us, it's not a problem for us. So they were thinking of going with this, publishing a statement along the lines of, we just weren't affected. It's not a problem here, nothing to see, move along. And I kind of forgot about it. This would have been the morning of the 9th, I guess. And then about 2, 3 o'clock in the afternoon, when we were looking around to see the statements and announcements that are out there to update that list, I noticed that they still hadn't. So I phoned him up, and I was like, where's that statement I thought you guys were going out with? And it turns out that before he went out with that, he thought he'd just check through their vendors and suppliers and their upstreams and downstreams and just think through that whole problem. And of course, he unraveled that there was at least half a dozen companies that they were directly interconnected with that were entirely exposed to the vulnerability, and therefore they would have been kind of misleading their customers if they'd gone out with it. So that got me to really thinking about the scale. And so early on when we were looking at it, it's like 5% of the potentially internet-connected devices or 20% or more of SSL was affected by it. But I suppose as it unfolded, I really was shocked at how prevalent OpenSSL was in so many other devices. And the reason I found this amusing, even in the early stages, is I was like, this is an open source project that's run on the smell of an oily rag for a number of years, and yet multi-million-dollar companies have been plugging it into the back end of their infrastructure and seemingly not contributing that much financial return to the project itself. So that kind of intrigued me, amused me at the time. The list of affected companies that we were having to push around to people was quite eye-opening from a security perspective. The other thing that it kind of amused me as well is that obviously as it then turned out, this is quite an old vulnerability that had just been discovered or just announced anyway. And so that got me thinking, so not only are all these companies using it, probably not contributing back to an open source project, no one's actually code reviewed it either. How did that get past an audit team? And what kind of review was that? So there was a couple of big unanswered questions at the end of that 48 hours, and a few other questions that when we thought through it sort of cropped up as well, which I think will come out as we go on. But that was our first 48 hours. I thought I'd talk it through, especially to share the legal experience. I'm happy to take any questions now or as the session goes on. Cool. Thank you.
Thanks, Barry. No problems. That was a pretty comprehensive run of events for 48 hours. That's great. So, Megat, if you don't mind, if you could talk about your perspective and of how it was, that'll be fantastic. Thank you.
Okay, hello, hi everyone. My name is Megat Muazzam. I'm the head of MyCert, Cybersecurity Malaysia. Okay, my focus will be on a Malaysia perspective, on how we deal with the heartbleed issues and how we going to mitigate the problems. It's more on our proactive measures. For your information, cybersecurity Malaysia, we provide 4 core services: cybersecurity emergency services, security quality management services, info security professional development and outreach, and also strategic engagement and research. Okay, my set is under cyber security emergency services, in which that we cater, we respond, we escalate incident related to cyber threats. Okay, incident reported for 2014, as you can see in the chart, from January until July 2014, we received 5,000 incidents. And out of 5,000 incidents, 20 incidents related on vulnerability report. For the month of April alone, we received 9 incidents, which is specifically related on the heartbeat issues. Okay. What is actually OpenSSL version 1.101 through 1.01F is affected for this particular heartbleed. A severe memory handling error in the implementation of the TLS heartbleed extensions. So due to this vulnerability, weaknesses allow stealing the information protected under normal condition by the SSL or TLS encryption used to secure the internet, in which that the attacker may access confidential information such as the session ID, server private keys, and also password. Okay, during the problem of this heartbleed, lots of proof of concept is available in the internet. Normal internet user can just simply pick it up from the webs and they can test out. Due to this impact, the severe impact, our team itself, myself, we also need to verify how extensive, what is the problem. So we also need to check, verify, and based from our punya testing, technical testing, it's confirmed, verified, and this is a very big problem that we need to address to our constituency. During the heartbeat issues, we can also see lots of information available in the internet. All the result can be easily been searched by using the Google search, and this information can be used by the hackers. So we have to try to address the issues and need to resolve the problem and notify our respective stakeholders, government organization, and the user on how to resolve the problem. Okay, one of activities that our team have done is that we have created a detection site, a verification site. Myself, I provide a tool to assist system administrator to check whether their HPC website affected by these vulnerabilities, and with this site verification, user can use and can verify whether their website is vulnerable to heartbleed. From 9 April until 6 of August, this is number of scan result that we received from our site verification. Out the number of total scans, 6,486. Until now, there are still 40 domain that is still vulnerable. So we still have to address. And with this information, my set can easily identify which domain that is being infected, that still have the vulnerabilities, and to notify the respective agency for them to take action. Other than that, my set also release advisories and provide awareness to the public through social media, website, and also through our special interest group. For this particular vulnerability, myself have released 2 advisory. The first one is alerts to inform our constituency that these things will happen, and we have to take care and to be aware of the problem.
Okay, Mgad, sorry, could we wrap it up? We really want to get into a discussion.
Okay, sure,
so thank
sure.
you. Sorry about that.
So I think there will be a few more slides.
Okay.
Okay. Okay. Okay, beyond Heartbleed, so due to this vulnerability, the system administrator need to do lots of things. They have to check the inventory of their hosts and the software that they run in the organization, read your logs, control your network parameters, talk to your users. If, let's say, the user been affected by this vulnerability, they have to do the necessary action. And of course, patch, update, and also upgrade. Okay, lesson learned due to this Heartbleed issue. Don't use the same password in multiple places. Even though you use a strong password, still you need to ensure that the same password is to use for other services. For example, your email, your credential, banking credentials, so on and so forth. Change your password at least once a year. So that should be your best practice. It should be done regularly. Use multi-factor authentication where available. Password manager can be your friend. And last but not least, be very suspicious of email that asks you to verify an account. This is due that there is a possibility that the hackers, fraudster will try to send a phishing email and try to get the confidential credential and information. Okay, this is our Cyber 999 contact number and information, reporting channel. So user can call us, and I think with that I conclude my presentation.
Thank you very much for a great show what the perspective of Malaysia CERT. Fantastic, thank you very much. I'd like to be able to go into something which is a bit more free form, if that's okay. What we've had is basically, let's figure out what was open SSL Heartbleed issue. I just want to really quickly go over, for anybody who's not so sure about it. A packet, an issue was introduced to a certain particular stream of development. The issue was this: you send a packet that was a little bit malformed, or a request, a large response, and you would get information from the server's memory. 64 kilobytes. It doesn't matter. And of this type of information were passwords, private keys, anything that was in the memory. Anything. Now, the internet is definitely made to work, just work. It's not supposed to be secure. And OpenSSL was provided to give a free solution to put encryption, to put security around it. A lot of people depended on that. Businesses depend on that for data transactions, right? Okay. For anybody who knows about this, Enigma, before it became Enigma machine, before it became popular, was used for business. It was actually marketed for business to be able to provide secure communications for their so competitors wouldn't take it. Now, it seems, as if it was a story for the Three Little Pigs. One of the Three Little Pigs decided to make a brick house because he knows straw and wood is not good enough. Got a plan from the internet. Knows that everybody else makes brick homes like this, with this particular plan. The big bad wolf figures out you puff and puff in a certain particular way, and just because of the design, the walls flip open, the walls flip closed, just for enough to be able to see where the keys are. How do we come to this? How was that particular issue was able to infiltrate into this development? I mean, after all, it's kind of open source, isn't it? As far as I understood, open source, everybody looks at it. Everybody has a go at it. Oh, no, is it? Paul, this is a...
So, first I want to say, open source does get looked at, not as much as proprietary source. So for the commercial proprietary versions of this type of software, this type of bug would have been found sooner. And that is a big change. I recall 15 years ago, back in the era of bind version 8, we found a bug, and it was not currently being exercised in the field, so we had to fix it. But we knew that the fix would immediately point to the bug, and that the fix would get out, and a lot of people would start utilizing the vulnerability before we could get widespread patching to occur. So I rewrote the entire other file somewhere. I just completely recrafted the logic in order to get the community to start arguing with each other about where the bug really was. And so the patching was able to get out long in advance of anybody starting to exercise the bug. That kind of trick used to be necessary. Now it's not. And I think there are a couple reasons why it's not, right? This was put in 2011, and nobody looked at it. You would have thought that a bug like this, somebody would like to get famous for discovering it and for saying, hey, look, I found this important bug. Look how smart I am. You should hire me. That's how it used to work. Apparently, all of those people already have jobs. And furthermore, apparently there is now so much open source code that there isn't enough man hours or woman hours, person hours left in the clock to start looking around at this highly sensitive code looking for bugs in the way that there used to be 15 years earlier. So we've crossed into a new space where we cannot count on the openness to drive the QA. And we actually have to figure out where the quality assurance and the testing and the red teaming is going to come from for stuff that we used to be able to count on the community to do for us, more or less in exchange for the value of receiving the software the community used to provide testing. That's not happening anymore. Now, the second half of that story is that I spent 18 years I founded a company called Internet Systems Consortium, and we did bind for many years. I'm not there anymore, but Jeff over there is still running it, and God love him. But what I found in my 18 years of running ISC was that the way that you paid for whatever it was, the salaries, QA tools, whatever it was going to be, is what we used to call midnight engineering. In other words, you would steal what you needed and beg for forgiveness. And that, again, worked fine when the internet was tiny. It does not work now when it takes a team of 40 or 50 qualified people who don't want to work as volunteers to actually work on the parts of it that are not fun, which is to say looking for bugs and fixing them and so forth. The money for that's got to come from somewhere. So sensitive as I am to the time, I want to say I went to a first-tier software company that included bind in their software, and I said, I would like you to join the bind forum, and that'll cost $50,000 a year, and this is what you get, basically nothing. The nice, good feeling knowing that you're paying programmers to go work on this. But we didn't give them any early access to software. We didn't give them anything that they couldn't get just by waiting for us to release the next version. And he said, well, no, I can't do that. Given that I'm going to get the software anyway, I cannot in good conscience go to my manager and say that it's in our best interest to pay this money. And that's got to change. It is in their best interest to pay that money.
Now, I also like to draw the fact that you also had some reservations of releasing fixes, because once you release a fix, it really points to the vulnerability and people have a go at it. It may describe, I just want to talk about to people who handled the incident itself. Did you find, you said that you found a lot of people scanning straight after the 7th of April or 8th of April, depending on which time zone.
So yeah, it was observed by one of our managed security service provider companies. Even if their customers weren't protected, they're able to sit them behind a CDN style protection, so they they were observing this scanning activity. Yeah, pretty widespread. I would have said that was probably New Zealand enjoys a little bit of security by isolation. So if we were seeing 40%, I dread to think what North America was seeing, or Europe, so or even some of the larger Asia economies.
And how? What about Malaysia? Could you go over the peak? I believe you showed sort of some kind of a Poisson distribution.
Okay, that information is more on our site verification, in which that user can check whether the domain website is affected by the heartbleed. But of course, during the first 1 week, there is a peak of user using, and the site is vulnerable to heartbleed.
What I want to highlight in this sense is the fact that on the public release was of the vulnerability was on the 7th of April, around about 7 o'clock in the evening, their time. It came public. The people who were coding were sure to be able to know that once it becomes public, it points to a vulnerability. It will point and will make attacks. The thing is that, here we go. How and when did they actually know about the problem? And did they coordinate with other people who have to mop up? Okay, the CERT community, actually, you just heard, 2 of them, people with response, even myself, received the information on the 7th of April or 8th of April, depending on the time zone. We know there's going to be attacks. We have to verify, because, you know, sometimes when you hear that the internet is going to be broken on the 1st of April because the root servers are going to be taken over, you just go 1st of April? Yeah, sure. So 7th of April is not that far away from the 1st of April, and when you hear that all banks are going to be open, you just go, yeah, sure. Give me the proof. Some of the tools that were available were a bit hard, so I don't know. So just to have a quick look at the time zone, just to realize at the time, Neil Mehta, from Google, on the 21st, apparently, of March, 21st of March, way before the 7th of April, goes, hey, there's a problem. Google patches their servers on the 21st of March, the same day. 10 days later, talks to Cloudflare. A day later, text to OpenSSL, by the way, you've got a bug. There may be a culture here, I'm not blaming them, because even with other software, you want to make sure that things are fixed before you tell everybody else. But it wasn't propagated through further on. I mean, I don't know. How did you go? You used some test tools, right, to be able to try. But we had to use a test tool. We had to figure out. It took us, first we used the one which was online, which we didn't trust because, you know, it may be a 1st of April thing. Yeah, it'll give us a false positive. Sorry, Paul, you've got some.
So in phased disclosure, vulnerability disclosure, you used to be able to say, let's make the, let's say, root name server operators aware first. Let's get that patched, because if the vulnerability is going to be obvious once the patch comes out, then you want everything that if somebody attacks it, the internet dies, to be patched before we do wide disclosure. And so you'd pick some inner rings of trustworthy individuals, root name server operators being an example, but you would also pick software vendors. You'd say, all right, I want to make sure that when we go public with this, that everybody at, let's say, Red Hat, SUSE, Microsoft, Apple, all of their customers are immediately going to press the update button. You want to make sure that the software that they would then fetch at that instant is already updated. That means we have to pre-disclose to those vendors weeks in advance to give them time to roll new packages and all the rest of that. None of that was done with Heartbleed. And I think the reason none of that was done with Heartbleed is that there wasn't an obvious hierarchy. There wasn't an obvious group of people who needed to be told first. This code is so omnipresent, it's everywhere, that, I mean, where would you stop? At which web server vendor would you say, okay, I know you're incorporating this SSL library, therefore I'm going to tell you. How do you know to trust that guy? It could be, you know, some mad Russian somewhere pushing out Nginx, and it turns out those guys are quite trustworthy, but not everybody knows that, right? That the world is not organized to be able to do phased disclosure at scale. That's, again, something that used to work when the internet was small.
It's not phased disclosure. There's some forums of information security teams and response teams that actually publish pretty much, if you want to talk securely, talk to us. There's these conferences where actually you try to talk. Google has a handle where you can talk securely, and they, through those particular items, can talk to certs, see certs, whatever may be, to be able to provide that information and saying, by the way, under embargo, tell your constituency as best as you can, or try to figure out how to be able to take care of it. And it sounds kind of weird, or at least here are the tools. Get ready, because we have to get disclosed at this moment in time. It sounds pretty hard. Yeah, sure, the internet was small, but there was no time for certs to go, which tool am I going to use? Am I going to use SSLY test, which actually grabs the 64K bits, which is actually illegal in certain places because you're grabbing unencrypted data. So where did it go? Inner circles, yes, inner circles. How do we expand this inner circle? That's the question. How can we expand this inner circle if the internet is now just too big to, that big? How do we go about it? Any question?
I suppose it's almost an impossible question to answer. You could probably do a better job next time, providing it followed the same pattern as the way Heartbleed unfolded. But as we know in the history of these sorts of things, that's almost never going to happen. You can only. When I used to in the military, and we often used to moan about our exercising regime because you're only ever as good as your last operation, because you always exercise based on the last war you fought, and obviously you don't fight that war ever again, so yeah, kind of pointless. So yeah, I'm not sure you truly can. There's some lessons we took around trying to spin up in an operational capacity and the obvious gaps that we identified from a local New Zealand perspective that we've taken steps to close in the short term. Obviously some legal issues that we'd still like to address. But yeah, I'm not sure on a global scale. There's some very useful sources of information on those inner trust circles that would have been invaluable to us in separating the wheat from the chaff, but I'm not sure it scales to be able to actually deal with this in a timely manner.
Right, because one CERT actually came up, CERT Australia came up and talked about these things are going to keep on happening. It's the local, it's what expected. You've got software vendors that comes out with, there's some vulnerabilities. So one way or another, if another piece of code runs on next to nothing for development, it's going to happen again and again. So the pattern is definitely there, isn't it?
I think the pattern's well established, but I think we should look at our part here, the four of us in these chairs, our part of that pattern. So at its height, the Configure worm had 11 million unique IPs per day checking into the sinkhole. I still operate that sinkhole, and I can tell you that the number got down to 1 million uniques as of 2010, and it has been 1 million unique IPs checking into that sinkhole every day since 2010. So getting from 10 million to 1 million was, I think, a very good step. But the fact that those other million are going to stay there until motherboards begin to die is something that we as a society need to look at every bit as much as we look at the disclosure process itself. I stopped notifying all certs within my hearing about new bind vulnerabilities when I discovered, shatteringly I might add, that they had their own disclosure obligations where certain certs in the world have to tell certain law enforcement bodies about a certain class of bugs, and they are required to keep that disclosure secret from me. And that meant I was out of control where I needed to be in control, but I was going to be out of control the moment I started what I thought was phased disclosure. I think in the Kaminsky bug, where we discovered that recursive DNS servers were trivial to poison, and by the end, I have to say, at first it took 11 minutes to poison a DNS server, but once the true experts got involved in gaming it, they got it down to 45 seconds. We surveyed all the name servers in existence to try and find out which ones had the type of randomization that would make this difficult. And we watched the trend line go down, and we eventually got it to the point where only 60% of the recursive name servers on the internet are still vulnerable to the attacks that he identified in 2008. And that we're going to live with that our whole lives. And we can sit on a stage like this one every year for the rest of our lives, and we won't have fixed those problems. This thing with the Heartbleed has an extremely long tail. I will bet you that 25 years from now, there are still things out there willing to give up their private keys to anybody who asks them. What are we going to do about that?
For 25 years, the private keys... sorry, there's a question.
You're right.
Oh,
so my...
I invoked you, sorry.
No, you're right. My question was around... So Heartbleed specifically, there was obviously, like Barry mentioned, you know, a logo and a huge amount of media, right? How much do you think that contributed to the whatever percentage it was that was patched within, you know, like a few days or a week or two? Obviously, the rest of the stuff is just going to exist, you know, like we've talked about. 90% was patched, the other 10% will stay indefinitely kind of thing. With Heartbleed specifically, do you think it was the logo and the media attention and that sort of stuff that helped? Because, I mean, you guys have far more experience in this space than I do, but for me, it seemed like there was... It got dealt with quite quickly. You know, say whatever you will about the disclosure process, vendors, whether they were network vendors or software vendors or whatever, did push patches out quite quickly once they figured out what was going on kind of thing, which to me, a lot of other guys, or a lot of other things that we see, some vendors pick them up, some don't, you know, so, whereas this seemed to be, no matter who you were and what you did, you had to have some sort of position on this, and that was usually, here's our patch or our recommendation or whatever kind of thing. I'm just curious how much you think that side of things played into this one particularly.
So the availability, the timely availability of patches was definitely useful. I go back to my shame some of those multi-million-dollar companies hadn't done the code review in the first place. They clearly understood it enough to be able to patch it so quickly. No, the media attention, and from when I was in government, I often was annoyed when there was too much media attention around an incident. In this case, I was actually pleased. I was going out and trying to get media attention and making sure we had the right message for that. The number of things that were patched in the first 48 to 72 hours was unprecedented, I would have said. I had members coming to me from large organizations and academic institutions, and they were saying, you know, they only actually had a tiny exposure to this vulnerability compared to some of the other things they've had to deal with on their networks, yet because of all the attention, their management was quite happy to waive change control. The patch never went through testing, and they just rolled it straight away. And so whilst I don't endorse waiving change control and not testing before deploying, that it certainly, you know, took the brakes off in a lot of organizations to fix things very quickly. And that's purely on the media attention.
So a patch which is timely? Hang on, the patch came out on the 7th, okay, of April. At the same time it was actually tweeted out, well, thereabouts, I'm pretty close. Is that timely? Is that a timely patch time?
No, the patch needed to be available before anything got out of its original lab. But I did want to challenge the question where 90% of what we can observe has been patched. Well, one of the things we know is that a certain generation of HP lights out logic boards would simply reset when you tested them for this. And that means that large data centers filled with hundreds of thousands of servers went dark when they were tested for this. And most of those data centers, believe it or not, are behind firewalls, and we cannot test them from here. I guess that's good for them because we could shut them off from here too. But if 90% of what we can reach appears to have been patched since this disclosure was made, I think we can assume that that is a very small amount of the total number of buggy systems out there. And if you got inside various firewalls, which a lot of our malware does, you will be able to exercise this bug in a lot more than 10% of the long tail. Saying that 90% got patched relatively quickly would be patting ourselves on the back unduly.
Okay, we have another question. Could you state your name and your organization, then the question? Thanks.
Sure. My name's Jeff Osborne. I'm with ISC. Paul put it really well, but I thought I should to try to say a little more. A lot of organizations looked good in the follow-up as they fixed the problems that they themselves caused. Heartbleed was a self-inflicted wound by the commercial entities that used OpenSSL. The total amount of money given globally to help the, 6 or 7 guys who were writing that was $2,000 in 2013. How many orders of magnitude greater than that was the amount of profit made by people who used OpenSSL? I would argue it's 10, 12 orders of magnitude. So the problem we have is very basic, and Paul's more familiar with it than I am. It's how the hell are we going to pay for open source software, which is a terrific thing of value, but falls into the whole tragedy of the commons problem. So while it wasn't sexy, nobody wanted to give money to the people who were doing this, and then once there was a problem, they rushed to show how quickly they had fixed the skin knees of the child they had pushed down the stairs. So this is the problem that has to get fixed. This is the root symptom. The problems of how you patch the software and how you phase the disclosure are all very interesting, but until we figure out how to pay for open source well enough that it's QA'd well, that people can afford to do a phased release of information, then we're just setting ourselves up for a whole series more of these.
I agree, actually. Just the fact that the internet is pivoted on those particular type of code, trade as such, as well. You got to have some kind of feedback to these projects. I mean, like I said, orders of magnitude. The thing is, particularly with OpenSSL and Heartbleed, the thing is that once you're able to see that it's vulnerable, you're able to get the server memory. It's still there. If we can say, oh yeah, we've patched 90%, can we put a pat on our back saying we've done a pretty good job, there's only 10? If you believe the scans that University of Michigan has set out, the PDF, there's only 3% which is out there. Can we put a pat on our back saying, yes, okay, no problems, there's only 3% and that's good enough? Hey, hang on. These servers that are out there are actually still vulnerable. You can get the 64 kilobytes. There's no like, it's 3% of the problem, that's it. People who wanted to secure their sites are now still vulnerable. Just as bad. They get completely owned as such if you're able to pull out those keys. So if we are going to be here for 25 years, we've got 25 years before the tail end goes out. We've got 25 years of people being completely and utterly owned over and over and over again. Why? Because they didn't patch. Why? Because their keys are out there. Even a nightmare, the keys, if the private keys were taken and they haven't been changed correctly, it's still out there. That may be another topic because I think we're running out of time. So I want to bring out to you again, how can we be able to get those 3% done as soon as possible if they're still out there? How can we communicate? How can we communicate to those 3% faster than 25 years before motherboards come off?
To the extent that these infected devices have internet identifiers, and there are organizations like APNIC that are responsible for internet identifiers, I actually think that the internet governance organizations could play a bigger role than they currently do. Right, there is an endless stream of noise coming toward everybody on the internet, whether it's spam, complaints about spam, warnings about your vulnerabilities that are actually spam. It's very difficult to sift through it, and I think most of us are now numb. And I think most of us, the day we woke up and heard that Heartbleed was a problem, we just said, oh God, I do not have time to deal with this on top of everything else that my hair is still on fire from yesterday. What is this? And that's what the enterprise computing world is like. So I would challenge APNIC and Aaron and the others to possibly see themselves as a role of a trusted introducer to where they could give a high-quality signal to the owners of certain IP address blocks to say, you are still checking into the config or sinkhole, you are open to DNS poisoning, and you are vulnerable to the heartbleed thing, and you're paying us money. We're telling you on a very private, very high-quality channel, please don't ignore this. Let this be the one thing you pay attention to today.
How would you? Sorry.
Sorry.
Yeah, there's a question.
Well,
your name, your organization. Sorry.
Okay, my name is Eric from Hong Kong. Actually representing the Professional Information Security Association in Hong Kong. While I'm in Hong Kong, I actually conduct the Heartbeat seminar with Hong Kong CERT along with the APNIC. And doing some research and scanning, we found that indeed, because the people in Hong Kong not only aware, they're aware of the Heartbeat, but the point is many of them actually using the version which is not vulnerable. As I know, that vulnerable part is based on some old versions like 0.x. Maybe I'm wrong, but it's not the version on the most updated one. So when the information brought out to the public, all server engineers are aware that maybe OpenSSL got some problem, and then they start to patch it. So the vulnerability servers, the number have a big growth after the first or 2 days. Then the patching again, and the number go back to the normal. So what I mean is the situation may not only appear is how the engineer or the guys are aware of the vulnerability or not, is how we publish the information to make them understand which version is vulnerable and which version they have to patch. As I mentioned, that the number shouldn't be so big until they patch, they try to fix the whole, but indeed the version they use actually is not vulnerable. So I think we have to aware how we circulate the information, how we publish the accurate data on that. So this is what I observe in Hong Kong. Thank you.
Absolutely, have the accurate data and provide it to the right person at the right time. So in yourself, how do we avoid these 3%, just going through the panel, how do we avoid these 3% to be there lingering for 25 years?
I think Paul touched on the right idea. I suspect there's a chunk of the problem here because it's embedded in so many like network connected devices. We're not talking about just websites here. I suspect that the organisation or whatever IT group there is in there has no idea that they've still got a vulnerable device because they didn't know how to open SSL in the first place. So until they get that communication from a source that they can verify and trust, they're completely unaware of the fact that they're exposing their organisation or their customer base to this. So yeah, it's using a channel like the APNIC channel or other trusted sources to identify and contact them.
Okay. So you're suggesting that APNIC does all the scans? And no, that kind of information comes from which kind of organizations, or it would be a CERT, right? They could have a look whether they're...
I suppose if there's a CERT in the local community that manages the constituency in that way, there's so many different focuses. But so there's no one size that's going to fit every community, and I suppose the takeaway is people need to decide within their local constituency and community how best to address this, because you have to be able to talk to an organisation, quickly establish who you are, and explain to them in a way they can understand that they've got a problem. So and that's not an easy conversation.
True, you have to have that cooperation beforehand. That's true. Someone's got to collect some IPs of these devices that are available, or MAC addresses or IPs. Then they have to provide it to someone who's able to take care of it, right? Which is not within sometimes the CERT's availability, which may actually be then APNIC's responsibility. CERTs sometimes are able to use a who is, to be able to identify. Having that information is also which is quite correct, would be great. If we had objects that were IRT objects updated, we would be able to try to contact the organizations themselves a little bit more, perhaps reduce it to a 1%. Still not good enough, 25 years. What's your take?
For CERT perspective, for my CERT, usually if we identify that the particular organization, websites or devices compromised, yes, we need to provide all the information. We have to provide all the detail. We have to assist them on how to rectify the problem. So sometimes this organization is to rely on vendors. And in which that if they cannot fix it by themselves, they have to wait for that particular vendors to resolve the problem. And it sometimes have a problem, big problem, because they don't have any technical capabilities on to rectify, to do the necessary patches, and that is why sometimes the vulnerability is still there, and it also incurred costs. They have to spend. Without budget, they will not do it. So there is also issues in cost and also on the technicality on how to do the necessary patches and upgrades.
Yeah. So getting timely information in the right place. Well, it looks like that with a bit of more cooperation, we may be able to try to reduce that percentage as fast as possible, hopefully before motherboards start dying. So with a bit more cooperation, perhaps we can actually handle the OpenSSL Heartbleed in a faster time than 25 years. Thank you very much for the discussion, and I think this discussion will keep on going. The speakers will be available and panelists later on if you will have more questions. Thank you very much.
Thank you, Jeff. And let's give another round of applause for the good work that he's done and his panelists. That's all the time. That's basically all the time that we have for the security session this time around. We need to make way for the next session in this particular room, but we'll guarantee you next time at our conference we'll have similar activities based on the feedback that we get from the participants that these sessions can be quite useful. So once again, thank you very much and thank you for your participation. Look forward to seeing you around, and bye-bye.